So this video is going to be on the special types of right triangles. So there are two types of right triangles that we consider special just because, unlike the other ones, they have a very unique sort of ratio between the sides other than just the Pythagorean theorem. So remember, the Pythagorean theorem is something that's shared between all right triangles. A squared plus b squared equals c squared. Every right triangle shares that theorem. Uh, excuse me. But the special right triangles here also share another property about them. And the main thing is that when we have these special right triangles, we can actually solve them as long as we know at least one side. Pythagorean theorem requires us to have two sides. So again, the theorem is a squared plus b squared equals c squared. So to solve this theorem, we need to know at least two of these pieces, right? We have three variables. If we know two of the three variables, we can solve for the third one. But these special right triangles can be solved if we just know one of the pieces. And again, that's because they have a special relationship between their sides, special ratio. So let's take about the first one here. So the first one's called a 45, 45, 90 triangle. Now again, these are all right triangles, so they have to have a right angle in them. These designate the angles in the triangle. So these special right triangles are described in terms of what their angle measures are. So a 45, 45, 90 triangle is a right triangle that has a 90-degree angle, a 45 angle, and a 45 angle. Again, name 45, 45, 90. Angle 1, angle 2, angle 3. So this would be, again, if this is my right angle, that means this would be C, and then this we can call this A, we can call this B. So that'd be what the sides are. So again, we know the Pythagorean theorem, that's true for this. But what's also true, I'm going to erase these here for a second. What's also true is that if you have a 45, 45, 90, this is true, that the hypotenuse is root 2 times as big as the two legs. So put in variable form, what that means is that if I know that this leg here is x, across from the 45, then I know that this leg here is also x, because both these angles are 45. So if both these angles are 45, then both these sides have to be the same length. So these two sides are the same length. We'll call them x and x. And the hypotenuse is x root 2 big. So you take the 45-degree angle leg, you times it by root 2, and that gets you your hypotenuse. So that's where we get the 45, 45, 90 from, is x, x, and x root 2. The way I write that down in terms of ratio is I write like this. So I have 45, 45, 90, and I know that this is x, that is also x, and this is x root 2. So as long as I know one of these numbers here, I can use equations in algebra to solve for the other two. So for instance, just as an example here, a 45, 45, 90 might look something like this. So here we have 45, 45, 90. It might look something like this. Let's say that this side here is 5. If I know that this side here is 5, that's an ugly 5. Let me try and make that a little bit better. Do, do, do. There we go. So if this side here is 5, that means I know that this side here is also 5. Because again, I know that the two 45-degree sides are both x, or in this case, they're both 5. And that means that this side over here is going to be x times root 2. Well, in this case, again, x is 5, so it'd be 5 root 2. So that's what we mean by x, x, and x root 2. 5, 5, and 5 root 2. That's, again, the ratio that the sides share. If this was a 10, it'd be 10, 10, and 10 root 2. So again, same style there. So let me show you a typical problem or problems that would occur here. Basically, for these types of triangles, we have one of two problems. One is when you know the 45-degree side, and one is when you know the 90-degree side. Now, I just did the 5 one here, so I forgot that I had that on there. So let me change this number to something like, I don't know, 10. So if I gave you this problem and I said, okay, here's A, here's C, solve for A and C. Just solve for the missing sides of the triangle. Well, your first thing would be, okay, I want to use Pythagorean theorem, but I can't. Because if I try to use the Pythagorean theorem, I get 10 squared plus A squared is equal to C squared. And that gets me nowhere. I can't solve this for A or C because I have another variable in there. So I can't use Pythagorean theorem. So then I look and say, okay, it's a special right triangle. So how do I solve a special right triangle? Well, I look at what type of right triangle it is. It's a 45, 45, 90. So I'm going to write that over here. 45, 45, 90. I know that this should be x, this should be x, and this should be x root 2. That's just, again, the ratio the sides share. It's always going to be that way. 45, okay, mic is on. 45 is x, 45 is x, 90 is x root 2. That's, again, the special property we have these right triangles. Now I look through this here and I say, okay, well, this side right here, across from this 45 angle, that side's 10. Now it doesn't matter which one because they're both 45, so I'm just going to call this one equal to 10. because it's given to me. Well, if you just go down the list here, okay, if this is true, if x equals 10, that means down here, this is also going to be equal to 10. So the other 45-degree angle is also going to be equal to 10. So I know that a is equal to 10. And then this right here, if x is 10 here and x is 10 here, that means this, since it's x root 2, is going to be 10 root 2. So this side right here, the hypotenuse, is going to be 10 times root 2. Usually people want you to leave their answer like this. If you want to know what that actually is as a number, you just type it in here, 10 times root 2, and that'd be your answer. Again, root 2 is an irrational number, so it's a decimal that does not end and does not repeat. It's kind of like pi. So just like sometimes when you write pi, they want you to keep the pi in there. Sometimes when you do the root 2, they want you to just keep it as root 2 because 10 root 2 is a lot cleaner to look at than this right here. But that would be how you kind of go about solving these problems, is you say, okay, list out your three angles, list out your ratios, figure out which one of these three you know, because you'll always know one of these three ratios. And then using that one that you know, you backtrack or forward track and solve for the two that you don't. So let's take a look at another one here that's slightly different, because this time we have the 90-degree side, right? Now, this is not said explicitly as a 45, 45, 90, but if you have a right triangle and two sides are congruent, it has to be isosceles. And if it's isosceles, you know that these two angles here are going to be congruent, because if this is 90, in order to add to 180, these two also have to be congruent, so that they add to 90, and then 90 plus 90 is 180. Again, a little bit of triangle history there. But just know that if I mark the two sides congruent or the two angles congruent, as long as you know that this third angle is a right angle, it's the same as a 45, 45, 90. So all 45, 45, 90s are isosceles. Therefore, all isosceles right triangles are 45, 45, 90s. So we'll just label them here as 45 and 45, just so that we have it explicitly said. And in this case, again, you're trying to find the 90-degree side. So if we write our numbers here, 45 is x, 45 is x, and 90 is x root 2. Again, that's the special ratio these sides share. That's what we talked about over here. All 45, 45, 90s share this ratio. These two sides are the same, and this side is root 2 times as big. Now in this case, I know that the 7 rather, is across the right angle. So that means that this right here is equal to 7. So I know, if you think about this as an equation, I know that x root 2 is equal to 7. So x root 2 is equal to 7. Now, if I want to find out what these two are, well, these are both just x. So 7 is equal to x root 2. I want to know just what x is. So I'm going to just solve this equation. X root 2 is equal to 7. I want to know what x is, so just solve for x. And again, the way you solve for x, I see that's going to be x times root 2. So the way I get rid of times root 2 is I divide by root 2. Divide by root 2. And I get x is equal to 7 over root 2. Now, again, sometimes they want you to leave your answer like this. They'll want you to leave your answer in one of three ways, actually. 7 over root 2 would be one way to leave your answer. The other way would be to get the decimal. So 7 divided by root 2. And that would be 4.9, essentially 5, right? The 9 rounds the 4 up to a 5. So 4.95. Now, sometimes they'd also want you to write your answer like this. What they do is it's called rationalizing the denominator. What happens is that you bring the root 2 up to the top. You keep the 7 where it is, so 7 stays there. You bring the root 2 up to the top, so root 2. And then on bottom, you just put down you just put down whatever was inside the root, which is just 2. And that would be how you leave your answer. And just to prove you that these all are the same, 7 divided by root 2 is 4.94 or 95. And then if I do the third one, 7 times root 2 divided by 2 is also the same. So all three of these are the same way of writing the same answer. This one's called a rational fraction because usually in fractions, just like you don't like decimals inside fractions, most people don't like square roots or roots of any kind in the bottom of the fraction, just because it's kind of weird to think about 7 out of root 2. It's just a weird concept. So this is usually what people prefer to write it as if they're going to write it as a fraction, but any one of these three ways for me would be correct. So just to let you know the different ways of sometimes they want you to write it. But that would be how you'd solve this one. So this one takes a little bit more work because if you're given the 90-degree side, you have to do a little bit of algebra work to backtrack and figure out what x is. And I know that this is going to be what both of these answers are here because this is what x equals. So again, this type of 45, 45, 90 problem breaks down to two pieces. One is when you know the 45-degree side, which is the one right here, and then one where you know the 90-degree side, which is this one here. And again, you have to backtrack a little bit and use some algebra methods to solve for that missing variable. And again, this answer applies to both sides. So this is 4.95 over here, and this is 4.95 over here. Okay? Because again, it's an isosceles, so both these sides are the same. This is typically the easier kind of special right triangle. The next kind we're going to talk about is a 30, 60, 90 right triangle. It's by far, I shouldn't say by far, it's one of the more useful ones. It's the more useful one of the bunch because it occurs more often in theorems and problems. But it's also a little bit more difficult to concept because it has a different kind of ratio. So let's get into it here. So 30, 60, 90. Obviously, as the name implies, this means that you have a right triangle where one angle is 30, one angle is 60, and one angle is 90. Thus 30, 60, 90. And again, A, B, and C, or A, B, and C that way if you want to, but it still has the two legs on the hypotenuse, just like every right triangle does. A squared plus B squared equals C squared still. But this also has the following type of ratio. So just follow me here. Across the 30, that's going to be our x side. If you notice, all these ratios are described in terms of how they relate to the smallest side. So the smallest side in this right triangle is going to be called x. And the reason I know that this is the smallest side is because it's across the smallest angle. So smallest angle across that is the smallest side. So this side we're going to call x. The 60-degree side is x root 3, or basically root 3 times as big as x. And the 90-degree side is twice as big as x. So the 90-degree side is twice as big as the smallest side, and the 60-degree side is root 3 times as big as the smallest side. Or again, the way I would write it out on the side, 30, 60, 90, 2x, and then this would be x root 3, and this would be x. And so once again, you'll be given one of these three numbers, one of these three values, and you have to backtrack to figure out what they were originally. So again, a little bit weirder orientation, I know. By the way, if you want a proof of any of these, you can look them up or ask me, and I can show you what the proof is for them. Again, I don't want to waste time going through the proof about why this is true, just because, again, it's kind of a strange period in education. But that's what the ratio is here. Smallest side we call x, then we build up. So next biggest side is x times root 3, and then the biggest side is twice x. And the way I keep these straight, by the way, is, again, these are both x times a number. This is x times root 3, and this is 2x. And since this side is the hypotenuse, this should be the biggest number, which means it should be multiplied by the biggest number. So the reason I know that this is the hypotenuse is because root 3 is just 1.7. So x times root 3 is going to be smaller than 2x. Therefore, x times root 3 should be across the 60-degree side, and 2x should be across the 90-degree side, because I want this to be the bigger number overall. So if this was, like, say, if this was 4, then this would be 4 root 3, and this would be 2 times 4, which is 8. And again, this would be the bigger number between all of these here. So small side is just the x, next biggest side is x times root 3, and the biggest side overall, the hypotenuse, is twice x. That's kind of the buildup that it goes through. Now, as you can probably surmise, this comes in one of three cases, where they give you the 30, where they give you the 60, and where they give you the 90. One of those three cases will be what happens. So let's go over how to do each case. We'll just take it one at a time. So I picked it again. So let me change this number. I swear I did not do that intentionally. Let me see. I used 12. I used 10. Let's change this one to, I don't want to use 3. Let's change this one to 7. I feel like we use 7 here. No? Okay. So let's change this one to 7. So across the 30 degree is 7. Well, let me write out my ratio here. So 30 is x. 60 is x root 3. And 90 is 2x. And that was my phone, my bad, sorry. So 30, 60, and 90. So let's go ahead and figure out how these are going to work here. So across the 30 is 7. So I know that x is equal to 7 because 30 across the 30-degree side is the x side, the smallest side. And I know that that side's labeled as 7, so x is equal to 7. So I know that x is 7, so that's one side down. Well, that means that 60 is x times root 3. And if I know that x is 7, this is just going to be 7 root 3. And that'd be my next side. And 90 is twice x. Well, again, if I know that x is 7, that means this is going to be twice 7, or 14. And that'd be my hypotenuse, my last side. And that'd be my answer. So when they give you the smallest side, in any of these problems, if you're given the smallest side, which is the side across the 30, or in the previous problems, the side across the 45, then it becomes really easy because you already have your base number, and you just need to multiply it by the right value. In this case, smallest side times root 3, and smallest side times 2. You just build it up from there. The tricky part comes when they give you the 60 or when they give you the 90. Particularly when they give you the 60, which is this one over here, which is why I saved it for last. But again, when they give the smallest side, which means we have the 30, you just build it up by multiplying that smallest side by the correct number for each jump. Now in this case here, let's write it out again. So we have 30 is x, 60 is x root 3, and 90 is 2x. So in this case, we have that the 90-degree side is 10. So 2x is equal to 10. So I know that this is true. 2x is equal to 10. Well, if I know that 2x is equal to 10, I can solve that equation to figure out what x is. So I divide by 2, and I get x is equal to 5. So up here, x equals 5. So I know that the 30-degree side is 5. So across here, that's going to be 5. Because again, 30-degree side is what the x is. So that means that that has to be 5 because I just solved for x down here. And if I know that that's 5, I know that the 60-degree side is x times root 3. So this would be 5 times root 3. And that'd be my 60-degree side, 5 root 3. And then I'd be done. So the 90-degree side isn't too bad. You just cut it in half to figure out what the 30-degree side is, and then times it by root 3 to get the 60-degree side. So again, you just kind of work backwards. If you notice here, all these problems, usually we're kind of boiling it down to find what the 30-degree side is. If you can find what the 30-degree side is, then you can just multiply it by whatever value you think you need to get to your next angle. But again, writing out these ratios like this first, 30 is x, 60 is x root 3, and 90 is 2x, can help sort of organize your thoughts and give you a place to start. Now the last one, again, this is probably the more complicated one overall, just because the 60-degree side is not a nice side. Let's write our ratios here. 30 is x. I don't know why I'm getting tongue-tied here. 60 is x root 3, and 90 is 2x. And we're going to solve. So if we draw a line here, it looks like that 12 is across the 60-degree side. So that means that the 60-degree side is equal to 12, which means I have my equation right here. X root 3 is equal to 12. So I'm going to go down here. X root 3 is equal to 12. And I'm going to solve this through. So divide by root 3, divide by root 3, and I get x is equal to 12 over root 3, which is how big the 30-degree side is. Now again, this is usually not how they want you to write your answer. If you're going to leave as a fraction, they want it to be rationalized. So usually what you would do is they would tell you to do this. Remember, rationalizing means take your bottom number, slap it up top, so 12 root 3, and then the bottom is just what was ever inside the root without the root, so 3. So clone this, put it up top, and then get rid of the root on bottom. Now, you might be noticing here that, okay, well, this right here, this is 12 over 3, this part of the fraction. And I know what that is. That's 4. So my answer can be simplified essentially down to 4 root 3. So this is x equals 4 root 3. That'd be the simplest way of writing my answer in terms of a fraction. Again, it gets rid of the division, it gets rid of the fraction entirely. It's just 4 times root 3 is what your 30-degree side is. So Again, if you're getting a wrong answer, it means you probably haven't rationalized your diameter, so your number might be right, but you might be using the decimal form or the non-rationalized fraction form when they want you to use this form. Again, that's why it's always important to upload your work so I can give you credit if you get the right answer, but just in the wrong format. So now, again, if we know that that's x, we know that 90 is going to be twice that. So 2 times 4 root 3, which, again, all you do is just 2 times 4, which is 8. This would be 8 root 3. So 8 root 3 here, and 4 root 3 there. And again, 12 there. And that would be your that'd be your triangle. So again, 60-degree side is a little bit messier because you have to divide by root 3, which again is not a nice number, and then you have to kind of backtrack to figure out what your 60-degree side is, what your 90-degree side is. But again, it's just as doable as the others. But I would highly recommend, if this is your first time or if you struggle with this, to write out these ratios at the beginning of each problem, or at least have them handy, because that will allow you to, again, structure your work a little bit better. You'll know which one you have. You can write that equation out, and then you have an equation there that you can use. So once you have an equation to kind of latch onto, then it becomes a lot more concrete, and the work becomes a lot easier to do because, again, you kind of have a roadmap now. If you start with no equation in sight and you can't figure out what it is, then you're just kind of floundering in the wind. So getting an equation can help, again, set you on the right path. So that's it for this video. Again, if you do have any questions or so, please feel free to email me or contact me, and I can try to help you out. Um, as always, make sure that you have a good, safe day. Also, if you see this to the end, you can go ahead and send me an encouraging or inspiring email, just so I know you're actually listening through the end. Just a little trick I'm going to try to do. So, otherwise, have a good, nice day, evening, or whatever it is currently.